The introduction to this video would contain awesome music, but record companies are being whiny bitches, so I can't use any. Maybe I'll sing karaoke next time. Hello YouTube, this is Logic Filter giving you the basics of logic. Meet A. A is a thing which has the property of being either true or not true. For example, it can be a statement or a collection of statements, such as "it is raining." Usually we call such things either truth variables or propositions. In itself, it is not very helpful. To get some use out of them, we must learn to manipulate them. For that, we use these. These are called operators. They combine two objects with the truth property into a single object, or otherwise manipulate the given truth value. The simplest operators are called AND, OR, and NOT. A and B is true only if A is true and B is true. A or B is true only if at least one of A and B is true. Not A is true only if A is not true. With these three, we can form innumerable different new propositions. There are a few more operators that we use. They can be constructed from the basic three, but we use the extra operators as a shorthand. The other operators are implies and is equivalent to. A implies B is true only if A is not true or A and B is true. It is often understood to mean if A then B. For example, "it is raining" implies it is cloudy, since it cannot rain without it being cloudy. A is equivalent to B is true only if either not A and not B or A and B. Essentially, this is the same as A implies B and B implies A. For example, "the traffic light is green" is equivalent to "the traffic light is not red," assuming a red-green traffic light, of course. One finds that both the implies and is equivalent to have an interesting property. Namely, if A implies B and B implies C, then A implies C. In mathematics, we call such relations transitive. When we are trying to prove a claim, we typically start with some statements we know or assume to be true, and try to find a chain of implications, or better yet equivalences, between the assumptions and whatever it is we're trying to prove. Assembling this chain of implications is known as deductive reasoning. It is important to realize that any results that we get by deductive reasoning are only valid if the assumptions are true and the chain of reasoning is correct. Incidentally, the other method for proving A implies B is to assume A and not B and derive a contradiction. That is to show that A and not B implies something that we know to be false. Now, some examples. Let us assume that A, B, and C are all true statements. Is the following statement true or false? Not A or B and A, and B or A and not C. It is customary to use 1 to mean true and 0 to mean not true. We're going to do this step by step. Watch closely. First, we replace all the A's, B's, and C's with their corresponding truth values. Then, we start working our way one step at a time. This concludes Logic 101. I hope it was helpful. As an addendum, I apologize for my prolonged absence. As reasons, I cite being busy with studies and being lazy. Another reason is that I was staggered by the vastness of the subject of logic, and I found absolutely no way to compactly explain it all. I feel that I will be returning to this subject later. Now, thank you for your time.